Hi, my name's Mark, and today I'll be talking about spatial mapping and its application to natural resource management, and more specifically in mangrove land cover and conversion around Australia. Spatial mapping is exactly what it says in the name. You are mapping one or more data features across space. There are many mapping softwares in use, such as ArcGIS, QGIS, and MapInfo, and even more. Mapping helps with understanding extents and allows easy visualization of more complex data sources. While species that are sedentary, like plants and coral, are most suited to distribution mapping, it's also suitable for mobile animals by mapping observations or habitat features needed for them to survive. When it comes to the judging effectiveness of management plans, spatial mapping has the advantage to compare or overlap multiple features as well as assess them over time by comparing multiple data sets. Mangroves exist primarily in estuarine systems, where they live in brackish tidal waters. They provide many natural ecosystem functions, such as filtering water and providing habitat to bird and fish species, while also acting as a buffer to protect coastal environments from erosion by dissipating wind and wave energy. They also function as a carbon sink, where mangroves sequester carbon at a rate 2 to 4 times more than mature tropical rainforests over the same area, and in doing so, store the bulk of it under the soil, as opposed to above ground like most trees. While they provide these benefits, globally, mangrove populations were historically removed due to the public perception of marshlands having no value. Factors such as strong smell and acting as breeding grounds for pest species like mosquitoes led to low valuing these crucial ecosystems, and so they were removed. Over time, new pressures have also occurred, such as land clearing for construction on coasts, installation of rigid beach infrastructure, increased pollution, and a changing climate have also put pressures on mangrove populations. In Australia, this has led to the loss of 278.5 square kilometres in mangrove cover between 1996 and 2016. In order to pinpoint which of the drivers led to the decreases and which spots have lost more mangrove habitat, spatial mapping provides an easy way to visualise the data. Mapping of the distribution of mangroves across Australia occurs as part of the National Forest Inventory, while an international effort to protect these specialised and threatened habitats also occurs with the Global Mangrove Alliance. Due to the remote and sensitive nature of the areas mangroves occur in, mapping is done through the use of satellite imaging, LiDAR sensing, and on-the-ground confirmation. The Global Mangrove Alliance has collected global data to map where mangroves currently and historically occur, highlighting areas that are both increasing and decreasing. Using the Mangrove Alliance map, you're easily able to compare the extent of mangroves in Australia between 1996 and 2016, allowing for focusing of resources. Spatial mapping can also combine datasets with other relevant information to better understand past, present, and future interactions. Largely in Australia, protections are given to estuarine river system mangroves occur in rather than the mangroves themselves. Mapping of mangrove distribution in vulnerable areas can show where focus is needed to stop further degradation. For instance, by downloading the National Forest Inventory 2016 dataset and comparing it to the Land Use Survey, mangrove regions that exist on private land are able to be identified, which allows for engagement with the landowners to maintain the mangrove's existence. The visual representation of data created as an end result of spatial mapping is a useful tool for the dissemination of information after analysis. On a regulation level, it may show the areas where you're not able to fish or access by boat, while at a development level, councils own land in their area for usage type and provide this information to developers and residents. Spatial mapping's ability to visualize data across multiple scales and disseminate information makes it a valuable tool in natural resource management. For mangroves, being able to pinpoint where habitats are decreasing and increase protections will allow the fish and birds that rely on them to continue existing, as well as keep the carbon they are sequestered locked away.